Meanwhile, this blue minion down here seems stuck, but it doesn't have to be stuck. CPUs actually use a concept of branch prediction. Instead of waiting to find out which way the orange minion decides we should go, the CPU optimistically assumes one answer or the other, and it learns this answer based on seeing the past patterns of code. The first time through this machine code, the processor will not have a good way of guessing which way this branch will go. But after it sees this branch taken a few times, maybe it always consistently jumps one way or the other. This particular branch that happens right after a subtraction, in our original code, that turns out to be the loop check here. So I less than count is how it's written in the C code. The compiler turns that into counting down, starting from the value count. And the thing about this test is count, it starts out at 1,000,000, and we gradually work our way down to 0. So if the processor guesses that we're going to continue the loop, it'll be right 999,999 times out of 1,000,000, which is a pretty good success rate. So the processor is going to learn this, and it's going to send that blue minion on around to the top of the loop so that it gets started on the next iteration of the loop. It is possible that the processor has guessed wrong here. Like after almost 1,000,000 correct guesses, it will guess wrong. So this blue minion has to do its work in such a way that it can be undone and not communicated to any of the other minions or to the program that's running if it turns out to be wrong. So branch prediction is enabling speculative execution. It's enabling this blue minion to get started early and probably doing work that turns out to be useful, although it's speculative and may turn out to be the wrong thing. I'm going to represent speculative execution here as a minion with a question mark over its head. After the orange minion completes the branch and decides that we really should go this way, then the blue minion is not going to be in speculative mode anymore. Whatever work it's done becomes revealed to all the other minions and the general system, and the minions keep going, doing their work in parallel. Here the blue minion is performing a comparison. We've got a branch that follows that, and we won't know which way the branch should go until that comparison is done, but once again, the minions can speculate on which way the branch is going to go, even though we don't have the input to that branch yet. And notice that this red minion that here is in speculative mode, it is needing to read from memory. This is why speculative execution can be especially useful, because maybe that red minion has to run out to the cache, or maybe all the way out to memory. Either way, it can get started on that big work early, while the onion minions are doing things that may or may not reach this point. But the red minion is still in speculative mode. So in speculative mode, it might add things to the cache. That's perfectly fine to move things into the cache, even if they turn out not to be used, if this branch is not where we're taken, because it's a cache of what's in main memory, and maybe in some other branch that we do take, we will actually use that data after all. So while the red minion is in speculative mode, mostly hiding what it does from other minions, it does affect the cache in a way that everybody can see, even if the changes that it makes to registers, say, are reverted. So this is all good, and again, it's a big part of what makes CPUs fast.